Okay, well before we start I should say that when I finally got around to reading the instructions yesterday I realised I'd have to change the whole presentation because it's going on YouTube, so I had to delete all the swearing, so bear with me. I have to play it fairly straight because sort of my management might be watching in the future. Oh, off we go. So I'm trying not to speak as a regulator here. Most of you know me, you know I'm bound to slip into type, but I'll try not to speak as a regulator, more as a problem solver and an engineer. We're trying to help people get it right. Occasionally we might slip though. So, notice my vibration control offshore solved in 5 minutes. How ridiculous is that? But the committee fell for it and I got the slot. We're dealing with a very complex environment out there. Although the irony is, most of what's in that picture isn't very noisy. The noisy place is below those exhaust stacks. That place is very noisy. It's 107 decibels everywhere in that room with 5 engines in. The guy that works in there quite likes it because he says nobody disturbs him. Sometimes the high noise areas aren't areas that we're concerned about because if you look carefully there's nobody in that area. 3 nice big turbines, well maintained, well enclosed. That isn't a concern to us. They're doing pretty much what we're expecting there. Sometimes we are more worried about lower noise areas. You need a good night's sleep offshore because you sleep next to the process. It becomes a safety issue if you aren't refreshed the next morning. And the noise you hear in your cabin could well be from the process above you, from the vibrating machinery above you, and I'll come to that later. So, who's got the power to make it happen? Is it the hygienists? Is it the health specialists? Is it the local medic? Is it acoustic engineers or HSE? We can't do it on our own. We haven't got the power. And it's often the people we don't meet that have the power to make it happen. So we need a cunning plan. We need to influence and persuade the right people, deploy the right tactics, and occasionally deploy a bit of subversion because the resistance is quite strong in some areas. We've got to outflank the opposition sometimes. So we're looking at a balance here, and certainly as a regulator, I won't mention that word, we have to think about persuasion or the law. And I've found occasionally, more than occasionally, that you go back after a couple of years after persuading them to do the right thing, and not a lot's happened. So that's been a waste of resources, and the workers haven't been protected. How do we get buy-in from the people with the power? The technical authorities, the production managers. You've got to learn to speak their language. It's not just the words, but the things that matter to them, identify that. You might just thump the table and point to them and say, I know you can solve this problem. High energy sources like reciprocating compressors. In this case, there are 3 in a row. Lots and lots of energy, 100 tons each. All this motion going straight into the deck, and in this case, cabins below. But high energy vibration can also lead to failure when you've got no tension. Through that small 8mm diameter hole came 1.5 tons of gas. That was on a reciprocating compressor. You've got their full attention now because that's what they're trying to avoid. Vibration leads to noise, but it also leads to failure. Now they're listening. So, excellent guidance out there from organisations like Energy Institute, your aging reciprocating compressors, small bore tubing, and coming to a bookshelf near you soon, Principles of Noise and Vibration Control Offshore. Probably next year, I commend it to you. Another one of my favourite compressors here, 6 cylinders. Everything in that picture has to be monitored very carefully because it's such a high energy source. It's going to fall apart, it's not getting any younger. It's 102 decibels there. Very high noise. What does good practice look like? It was so quiet there, I didn't even believe it was running. 83 decibels, no requirement for hearing protection. You can hold a normal conversation standing next to that machine. It does the same job as the other machine. New technology is available. So, radiating surface demonstration. I'm going to use a bell here as a radiating surface and move a bit of damping around on the surface. In that picture, there's one line, 30 meters long. It's 110 decibels close to it. All the other lines aren't interesting to me. That one line is of interest. How do we apply damping to that to make it quieter? Let's put the damping in the right place. Not the right place. Not the right place. Let's try there. So, we target the intervention. A very small amount of material put in exactly the right place does the job. So it's an engineering challenge. How do we put the minimum amount of material to get what we want? You don't have to cut everything in the picture with absorption. So it's an engineering challenge. Now, a few years ago I foolishly said to my boss, what we need is an engineering solution to this health problem. He said, no Bruce, if the engineers had designed it right in the first place, we hygienists wouldn't have to come along and fix it. So, touche, Sam. So, together we succeed by deploying all the available tactics, including the subversive ones. You've got to learn to speak their language. Drag them onto territory where you know they will start listening. So, as we sail into the sunset, remember the main thing is speak their language. And let's ring the changes.
Thank you, Bruce.